Okay, so this is Math 2, Lesson 831, and so in this we're going to be talking more about what we talked about in class, which was ratios of similarity, but we're also going to get into perimeter here, which we did not get the chance to do in class. We only discussed area and how it related. So Alice has a 4-inch by 5-inch photo of your school's championship ice hockey team. To celebrate the recent victory, your principal wants Alice to enlarge her photo for a display case near the main office. When Alice goes to the print shop, she has many sizes of choice: 7 by 9, 8 by 10, and 12 by 16. She's afraid that if she picks the wrong size, part of the photo will be cut off. Which size should she pick? And why? So, 7 by 9, 8 by 10, or 12 by 16. I think she should pick this size because it is similar. I need to multiply 4 by 5 by 2. And if I do that, this one, there's not a really nice, we add, no, and then this just I can times by 3, but not, that's going to be a little wide, so it's not going to be proportional. So I would choose 8 by 10 because of the proportionality. The cost for Alice's photo, if it's normal 4 by 5 inches, is 45 cents. Assuming that the cost per square inch photo is constant, how much should it cost to imprint the enlarged photo? So we have our 4 by 5. When I enlarge it, it will be 8 by 10. What happened to the square footage? So if we recall from class, the area, so our scale factor is 2, linear scale factor. Which will make our area scale factor 45 cents. Forgot what that was for a minute. Area scale factor will be 4 because 4 is 2 squared. And so how much will it cost? So 4 times 45 should be just under $2. Calculator's way far away. So $1.80. Okay. Unbeknownst to her, the vice principal has also ordered, oops, you can't see that part. The vice principal also orders an enlargement of Alice's photo. However, his enlargement costs $7.20. If the cost per square inch is still constant, how much, what are the dimensions of his photo? So we know that the scale factors, we don't know what the scale factor is, we know how much we spent. And so it was 45 cents times something, ended up being $7.20. So we need to figure out what it is. So 45 cents times something is $7.20. So we're just going to divide. X equals 720 divided by 45 cents is 16. So I times by 6, that's my area scale factor. Area scale factor. Wow, I can't spell. Scale factor. So what then is what are my dimensions of my photo? So what do I do with this? So to get from the linear scale factor to the area scale factor, I squared. To get from the area factor back to the linear square factor, what should I do? That is correct. We're going to take the square root. And so my linear scale factor is 4. And so my dimensions must have been 4 times each original number, so 4 by 5 times 4 will be 16 by 20. The dimensions. Cool. Pretty straightforward. Again, just applying what we did in class today. Okay, so as I mentioned at the start of this video, we hadn't talked about perimeter. So we discovered the relationship between areas of corresponding length and side lengths of similar figures, but how are the perimeters of the figures related? So ratio of sides, ratio of perimeters, ratios of areas. All right, so ratio of sides. So write fractions in lowest terms or calculate decimals. So what we're going to do, we're going to analyze these. There's 3 shapes down here. We're going to deal with what's the ratio of sides. We're going to find, and then we're going to find the perimeters, and then we'll figure out the ratio of perimeters. Same thing with areas. So 6 to 15, and then that's 25. So I'm not timesing by something very nice here. Just something to keep in mind. It must be timesing by something a little bit harder. Let's figure out what this missing side is. So 6 over 15 is equal to, well, actually, how about, yeah. So let's just start here. The perimeter is 6 plus 6, that's 30. So that's 42. Those are not units. Gray marks. Okay. 42 units. Okay. And let's find that missing side. Okay. So 6 to 15 equals unknown to 25. Sides that go together in the same parts of the fraction. 6 times 25 is 150 equals 15x, and so x is 10. So what is my ratio of sides? Well, then it's 6 to 10 or 10 to 6, 3 to 5, or 5 to 3. 3/5. Ratio of perimeters, so this is 10, so that makes this 20, and that's 50. So this is 60 units. We'll come back to the ratio of perimeters. Actually, let's do it 42 over 60, since I did small over big. 42 over 60, 6 goes into both of 50. Oh, no, that's supposed to be 70. Wow, bad mathematics. Like it's not working. 7 goes into both those numbers, giving me 6 over 10, which is 3/5. Interesting. Area. So the area of the original, 6 times 15, is 90. The area of the new one is 250. So 90 over 250, which is 9 over 25, which is 9 over 25, or 3/5 squared. Write that down. Yay, math. So these ones are a little trickier to find our missing sides, which are probably not in the rectangle. So this 6, making this 12. This is 4, making this 2. Height 6 radical 3, height 2 radical 3. Area small is going to be 1/2 base times height, which is 2 radical 3. Area large is going to be 6 times 6 radical 3, 1/2. 3 times 6, 18 radical 3. Ratio of sides is 2 to 6. 2 to 6, or 1/3. We can times this one by 3. Area ratio is 2 radical 3 over 18 radical 3, which is 2 over 18, which is 1 over 9. So again, still squared. Okay. Perimeters, though. We need to find the perimeters. Let's do that up here in purple. Perimeters equal 18, 6 plus 12, plus 6 radical 3. And the perimeter of this one is 6 plus 2 radical 3. P for small, P for large. And so if I set those up with small on top, 6, going back here, 6 plus radical 3 over 18 plus 2 radical 3. I'm going to go ahead and factor out 2 on the top, which is 1 plus radical 3. Oh, sorry. I'm going to factor and put it over here. Factoring out 2, I get 6. Factoring out a 2, I get 3 plus the square root of 3. Down here, I'm going to go ahead and also factor 6. That's a 6. Sorry, I'm going to factor out 6. 6 goes into 18, 3 plus radical 3. So those cancel out, thank goodness, and I'm left with 1/3. Huh, same, interesting. This one, what do you think? So without, we're going to not do this one because I don't think this video ain't ridiculously long. Perimeter is a linear factor. Do you all agree? Perimeter is linear. Yes? Area is square units. Perimeter is linear units. Volume is cubic units. We aren't even talking about volume, but area is square units, and volume is cubic units. And perimeter is linear units, and therefore has the same scale factor as the side. Right? It's the same scale factor. And since we're just adding, it's not going to get, the scale factor is going to stay there, constant. Does that make sense? Okay. So with that said, we're going to jump. We're skipping this thing about Alice. We're going to jump to 67. Jesse wonders if the two figures below are similar. Decide with your team if there's enough information. So what we know, what we can see is that the sides would be 7 to 21, which is 1/3 or times 3. So from small to large, looks like we have a scale factor of 3. Linear scale factor. Okay, so what's going on with the areas? So area, I'm going to put small on top, 360, which is 4 over 36, which is 4 goes into 36 9 times. And so if I flipped it, 9 to 1 is my area scale factor. Is that reasonable? Are they similar or not? They are. I agree. Because there's enough information. We see that the side scale factor is 1 to 3 or 3. We see that the area scale factor is that scale factor squared. So yeah, they're similar. That's enough information. It's kind of cool that that's enough information. And last but not least, we have one more question, and then we'll be done for the day. You know, you're all thrilled. We're done for the video. Your teacher enlarges the figure below so the area of the similar polygon is 90 square centimeters. What is the perimeter of the enlarged polygon? Be prepared to explain your method to the class. So the first thing we need to figure out, so areas, 100 centimeters squared to 900 centimeters squared is 1 to 9 or 9 or 9. So our scale factor is 1 to 9, or our area factor is 1 to 9 or 9 to 1. So what is the perimeter scale factor? Or linear scale factor? Is 1 to 3 or 3 to 1. Same difference. Big to large, large to small. Anyway, so let's find the perimeter of this shape. Perimeter of our shape, of our small, perimeter small, is going to be 8, 4, 6, 4, 5, 10. So 8 plus 4 plus 4 plus 5 plus 10 plus 13 equals 15 plus 13. 12, 15, 8, 13, 28, 30, 40. So my perimeter is 40 centimeters. What is my perimeter large? What are we going to do? We'll take 40 and times it by 3. So my large perimeter is 120 centimeters. Okay. All right. I'll see you guys soon. Have a great day.